Hello there, viewers. Today's video is going to be on this old Kenmore 1986 microwave. We're going to be taking a look at it on the inside and, well, outside, inside, and then internally, how it's set up. Now, I had bought this microwave, I want to say about 4 or 5 years ago. I actually use this myself, but mainly this one's in my room. This is, well, in my walk-in closet, so this is just kind of, I guess it's my main microwave, but I still use the kitchen microwave mostly. But in terms of when I don't feel like running it out of my room every 5 seconds to heat up, a snack or whatever, or some water to make some tea or whatever, just pop it in this little, this beast of a machine and heat it up. Now, there are some pros and cons of this microwave, which you'll see in a minute, and some things I don't like about it. But overall, it's a pretty decent microwave. Like I said, this is a Kenmore. You can probably see the old name tag down there in the bottom left-hand corner. I think this is 1986 is the manufacture date on this. We'll take a look inside first, but also, sorry about the backdrop cloth. I'm doing this on my computer desk because it's like 40 degrees outside and it's pouring down rain, so I don't feel like doing this in my shed, my workshop. But anyway, you can barely see it. I don't think you can see it, not on here, but you can faintly see the writing. Like you see the little UL thing where the ink is faded off. I'm trying to see. Yeah, I think the manufacture date is, I know it's 1986. Oh, there it is. January 1988. Sorry, 1986, 1988 is when this was manufactured. So it is a bit dirty on the inside. Haven't really cleaned it out a lot. It's just mostly sauce stains. But as you notice, this does not have a turntable. And I'll explain how it still heats the food up by not having a turntable in a minute. But as you can see here, you got your racks. I do have the racks, actually. It's like I guess for like cooking turkeys. Sometimes they advertise that, but or I guess grilling. I'm not sure. I've never used them, even in today's microwaves where they still come with these like metal racks you put in there. I have no purpose for them. I don't even know why they still put them in here. I mean, unless it's like a 2-in-1 microwave where it's a microwave and it has like a oven, like a pizza oven, like a combo. Other than that, I really don't see the purpose of using that, but they're still there. I just left them. It's all original still. We got our nice big heavy duty door here. It's probably like an inch and a half thick. And you got like your bolts here that go all the way around the perimeter of the door here. And of course, this is a solid state microwave. To a point, and like I said, well, once we open it up on the inside, we'll take the cover off and I'll explain what is solid state and what's not. But anyway, this is a solid state microwave. We're just gonna say it's solid state for now. But it's got programmed defrost. You got your keypad, your interval times. You type in the time set. It's not like your normal, like today's, they'll have like number 1 is like 1 minute, 2 minute, 3 minute, 4 minute, and so forth. You actually have to push time, and then you put in, let's say, 12 seconds, and then you push start. Of course, you have to close the door, and we'll do that now. But let's not run it with nothing inside because bad things might happen to it. But anyway, you just push clear when you're done. Then of course time of day, that's the clock and all that stuff. But it also has a cook control, and that is what this little probe port right here is. You actually hook a temperature probe into it, and then you stick it in the food, whatever you're cooking in here, and it'll measure when when it's thoughtly cooked out throughout the, say, I'm assuming this is like for hams or turkeys or something, like big stuff, or like casseroles, whether it's leftovers or not. And it just makes sure, you know, that it's cooked all the way through down to the middle, and not just like surface of it is heated up. So, but then you got your little temperature chart here. It tells you what's what it should be. I've never used it because when I bought it, it didn't come with that. It did come up with this little turntable that you sit down in here, and it's a wind-up piece. I got it over there sitting on the bench right now, but I'll bring that over in a minute, I guess, maybe. In fact, I'll do it right now. Let me just set you guys right here. Reach over and grab this. Oh, also, before I show you, the wood grain on it, part of it is actually textured. You probably can't see it in the camera. It doesn't look like it is, but you can actually feel it. It's actually like pitted. So this is actually textured on the wood grain finish of the chassis of it. This thing also is extremely heavy. Now here's the piece I was talking about. There's supposed to be another little piece here that you set down. I've misplaced that, unfortunately. But all you do is pretty much you just put this piece in here and you just wind this up, and then it's like a little wind up toy, and then it just slowly unwinds itself, and as it does that, it turns the table right here. But also on these older microwaves, as you'll notice, there is like a cover right here. You pull this down, and inside this is your waveguide. Now this is not motorized. It works by the cooling fan. So this is where your microwaves come out of. Your magnetron is sitting up here, fires the microwaves through this, and this directs the microwaves down. You see they're angled, and it fires them down in the, well, not middle, but the plate right here. But as the cooling fan sitting over here, it's a blower style fan. You'll see that in a minute. Blows past the magnetron, cools the magnetron, then it comes out of here into the oven area. And as you can see, these little plastic air guides, it actually forces the air to spin past this, and this acts like a little windmill. And so it uses the fan itself, and it just spins around. And as it does that, it guides the microwaves around and evenly cooks the food. And then of course, then it comes out the front here. You've seen these little vents at the top, right here, and then gets blown down in here, and then exits out the back through these back vents. And this also has another air guide where it directs it up and out, and not just straight out the back, and so it can get recirculated. So it just directs it up and out into the air. Now, I did modify this microwave, as we'll see here in a minute. I'm going to open it up for you guys, and I'll explain why I modded it and how I did that. So let me get you up in the stand, and then we're going to take this cover off, and we'll take a peek inside. So here we are. We're on the inside. It's actually pretty clean in here. I have not dusted it out, but I know it's very messy. But first we'll start off. This is the fan right here, the cooling fan. As you see, it's a blower style fan. This is how it blows past the magnetron, cools the magnetron, and then this is the other air duct where it directs it into the cavity and then spins that fan around. Now if you look here, you see the magnetron is actually firing in the up position, and then it guides it out forward or sideways into the chassis, away from it to the left. Other than that, of course, you got your magnetron. You got, actually, let me unplug this. It's probably a good idea before I just start poking around in here. Make sure it's all, okay, we're off. It's got a fairly, I guess, beefy transformer. The older ones are kind of more like rectangular. They're not like the newer ones where they're short and fat and chunky like. This is kind of like almost like a low profile design, I guess you would say. But anyway, as you can see here, this is the section I modded, I updated, which was the high voltage capacitor. Originally, it had a 0.86 microfarad capacitor, which was kind of, you know, that's kind of crap for a microwave. I mean, you're mostly going to pull more power than you are actually able to use it. And so I just went ahead and upgraded it. Now this capacitor right here, it was originally an 0.86 microfarad, and this is a 1 microfarad capacitor. So this is a very high capacity capacitor here for in terms of what this is being used for. So I had to mod it because the original capacitor, I think, yeah, it was sitting down in here. Let me position you. You see where this little lip is right here, and then there's a mounting hole. You can probably see where it's cleaner than the rest of the chassis here. It's like a stain mark. That is actually where the old capacitor was, but it actually stood in the up position like this. This one here, and it had like 2 brackets coming off the side. But the problem with the older ones is, if you see here, in fact, let me get my flashlight for you guys so I can kind of show you. The older ones, the high voltage diode right here was actually built into the capacitor. So the problem with that type of setup is if the high voltage diode were to fail just due to old age or over time, it would you'd have to actually replace the capacitor with it. And of course that would be, you have to spend more money, even though these capacitors are probably like $10-15 a piece, maybe 20 at most. I mean, the transformer alone is only like maybe $20 to replace in a microwave nowadays for, I think it's like a 1500 watt. But anyway, so I had to get another different bracket. I actually had to drill through the chassis here. Then I had to, I used the schematic from another microwave because all the microwaves, the schematics, like in terms of how to hook up the magnetron, are all the same. There's no different like setup, besides unless you're using an inverter system to where it doesn't use a AC, a standard AC transformer like this one down here. If it uses a DC, high voltage DC power supply, which is what the inverter ones are. But anyway, so then I had to ground out, of course, the one end of the diode to the chassis, and then the high voltage output from the transformer right here. You can see by the tag there. Hook that in one side, and then in the magnetron to the other side. But pretty much that's about it. I mean, took me maybe about 5 minutes to do. I just had to look at the schematic just to make sure I had everything right. But that's about the only thing I did. I think I did replace the high voltage fuse down in here, but I didn't need it. I just did it just because I just had it on hand, and I was like, why not? But anyway, if you look down here, there is a solid state relay. Now this is a terminal block, and this is right here, this big black chunky heatsink here. This is what powers the transformer right here. Now this is why this is solid state, because the transformer, instead of using a standard typical mechanical relay, this is using a solid state relay to turn the transformer on and off. But of course the fan and the light inside is still running on like small relays. But that's what they mean by solid state, is just the transformer side, or the microwave proportion is, or the transformer, the high voltage power supply is running on solid state. But that's about it. There's something else I was gonna say. Oh, when I did have this taken apart, there was like a almost like a PTC thermistor that was on this terminal block. Right down here at the back, you can probably see the 2 solder points right here. You see, it looks like something was soldered onto it. There was like I think it was a PTC thermistor, something of that sort, or MOV. I can't remember what it was, but it was like something for like almost like surge protection. But it actually was blown apart. It was split in 2, and it was burnt and everything. So I'm not sure what happened with that, whether this experienced a major power surge, like from during a lightning storm or whatever, and it tried to protect it, everything's fine, nothing's broke on it. It's just, I noticed that it was like a surge protector type of deal, like a solid state surge protecting device on there, and it was completely blown in half. It was split right down the middle, and it was all black and burnt. So I'm not sure what that was about, but like I said, everything else is pretty much in good shape. Let's see if I can get a better angle. to zoom out for you guys and hold the flashlight at the same time. So, if we look at the circuitry here, this is the motherboard. All these, now you can see the one relay there, two relays, excuse me. One's probably for the light and the other one's for the fan. You got your low voltage power supply transformer, and you got your safety interlocks cherry switches right here. Now the microchip on this is a NEC LM8688. And then there's other words beside numbers 553132. And then right after the word NEC, the brand, there is 8245EK. I'm not sure whatever number to look up. I'm pretty sure it might be the big one right there, the big letters and the numbers. Anyway, and then you got your VFD display here. It's got like some kind of pinout, whatever 34D, whatever that is about. Some resistors, your little buzzer speaker here. Now this, I assume, yeah, that goes down to the solid state relay, the output right here. This connects it to the control panel here. And there is, looks like that is a full bridge rectifier right there. Yep, that's a full bridge rectifier right there. Another full bridge rectifier right there. A little microcontroller right there. Now this right here is probably the which drives the VFD display. I assume, and this might be the actual processor. I'm not 100% sure on that. Or this might be both. It uses both of these right here. Now, one issue with the system is when you go to run the microwave itself, there is a problem to where when you run it, when it starts up, it's fine at first, but then once the magnetron and all kicks in, the display gets kind of dim. It causes a big voltage drop. So I'm wondering if I have to replace any capacitors in here. Because it draws a lot of power. I think this thing, last time I measured it, was like 13 amps when it's running, up and running total. But technically that's not bad. I've had other microwaves smaller than this, like newer microwaves, like from General Electric, and what's that other brand? Hamilton Beach, like your Walmart brand ones, and they draw like 14 to 15 amps, and they're only rated for 1,000 watts output, cooking power, and they draw 2 amps more than this. So, but yeah, here's this is your lamp right here, 30-watt lamp only. Now this is original. You can probably see it's all dirty down in there. This lamp, yeah, you can. Wow, it's actually got some black around the bulb on the inside. So yeah, it's got the original light bulb. Like I said, the only thing I touched or replaced was this capacitor right here. And of course, like I said, I had to modify it. Here's your blower. Here's a better look at it. Now, another thing about the blower is when it turns on, it starts off very like at low speed. And then as it heats up, the system runs, it slowly ramps up until after about, I want to say about 2 to 3 minutes of running, it finally ramps up to full speed. I'm not sure what's up with that. As you can see, it's directly hooked to the mains, to the light bulb portion of it right here. And then it's on its own little separate circuit style. But it's just a little weird how that does that. And there's no, I thought maybe there might have been like a PTC thermistor on that to kind of like a soft start for it. But I'm not sure. But when you if you mess with microwaves a lot, you know the little trick where you can just kind of halfway open the door up, but you get the light to turn on and the fan to turn on, but not the actual magnetron itself. If I do that, this fan will actually ramp up at full speed already. But as soon as I push, put the time in and push start, and the magnetron fires up, for some reason this starts at like a really low speed, and then like I said, it takes like 2-3 minutes, and then finally you'll hear it like ramp up to full speed. I don't know if it's just something in the circuitry. I don't see anything. I don't know if there's anything on the motherboard down here. I mean, there are some solid state components down there, but I don't know. It's just kind of weird. But yeah, that's pretty much it. Now I thought in the future I might upgrade this magnetron. I'm not sure because the way this is designed, I don't know if I'll be able to fit a newer model one on here. Because these older ones are kind of like custom fit, custom made. Um, before they all become a standard size. Um, I don't even know about the transformer because the way it's designed too, I might not be able to upgrade it. Because the old ones, not sure it says on this, but I think when I read last time, I had another one similar to this. I took apart, but it was actually scrap. It was rust. It was rust. The paint was peeling inside of it, and it was pretty bad. It's full of roaches and stuff. I got it out of it was going to go in the trash, which is kind of where I got it from. Well, it was somebody I knew. They were going to throw it away, and I asked if I could take it, and they told me sure. And I stripped it down, but it was a similar model to this, but it was an older. It was from I think 1978 was the manufacture date on it. But my plans were to salvage it. But I'm gonna tell you right now, this one, even though this looks a little dirty, this one's about 100 times cleaner than that one was. I mean, that one there's just grease over everything. It was disgusting. It was awful. I mean, there was just no point. It would probably take more time to try to repair it and fix it than it would to save it. But anyway, but yeah, but they use different style mounting brackets for custom because they weren't like all a standard base standard style like they are today. Anyway, but the transformers, um, oh, the one I was just talking about, I took apart and scrapped. It had a schematic in it, but the output on these transformers were only like 1,000 volts, 1,000 to 1,100 volts. I think 1,200 was like the max. So they're not really that great of a power supply, especially like I guess for nowadays. Given the fact that you were to get a microwave transformer nowadays and they put out at least 2,100 volts, so twice the amount of power, the voltage output, and then of course you got your capacitor doubling circuitry there, and that doubles it, so it's like 4,000, 5,000 volts. But yeah, so that might be the issue why this might not cook as great. It takes a little bit longer. I also thought maybe because the way this waveguide is designed, but I don't think that's the issue. I think the issue is mostly in because this transformer is not putting out enough power. It's just like the bare minimum for this magnetron to operate at. But I know I'm going off on a trail here. But anyway, but yeah, I mean it's a pretty nice little system. I like it. I'm gonna keep this as long as I can, for keepsake, but also because it's I guess a piece of history, and it's in really nice shape. So I don't see any purpose of throwing this out or scrapping it or whatever. At this point, like I said, I might upgrade the magnetron. I'll look in to see what I can do, and if I do, I'll put a video on that, or I'll do a video on it. But thanks for watching.